Good morning, everyone. This is Tom from Every Step Calculus, everystepphysics.com. I'm presenting this from San Diego in the morning. And this is partial fraction decomposition, as you can see on the screen. The reason I wanted to make a video of this one is because this has long division in it, because the denominator has less of a exponent than the numerator, so then you have to divide this and then use that in the partial fraction to set that up. So I wanted to show you how that worked. You might want to send this along or share this with other people, because Google prevents me, or I think it does, prevents me from getting on the front page of people that would search for every step calculus or step-by-step calculus, something like that. I've never been on the front page or even close to it, and so a lot of people don't see my great videos, and these are the best ever of any programs you may find, because they're in your backpack in school and college, or your purse in college or school, that you can use during your homework or test. The other alternative is, of course, online, is that you have it on your computer. Yeah, you can find calculus solutions, step-by-step problems too, online, you know, but then you have to have your computer with you, and that's at home or wherever you might be. So everything I program is in the TI-89 titanium calculator. There's over 900 programs there for calculus alone, let alone physics. And you buy my programs and install them in your TI-89 titanium calculator, and there they are. But also the way I program, because I programmed it for these when I first, years ago, 30 years ago really, when I got into college, San Diego State, and I needed it to pass all my classes, and I found that MIT had written this program not for Texas Instruments for themselves, I think, and then Texas Instruments somehow got a hold of it, put it in their calculators. But I'm still amazed at the program, how it works today, and why it works, and how great it is, because anything you can put on paper, you can, at least I can, program it into the calculator. So it certainly helped me to pass all my classes in college, and of course it would help you too if you purchased them. So let's do this partial fraction decomposition for integration. And you buy my program, then you're told how to put index 8 into here. To put letters in, you have to push, to put letters in the entry line here, you have to push second alpha, and then it puts the letters in, and you have to press alpha again to put the 8 in the open and close parentheses. The open and close parentheses tell the calculator that you want to do a program, and you press enter, and it goes to my main menu, which is the main function. This is many items in here, just like the index of your calculus book. P and Q point, pyramid optimization, Newton's method, etc., whatever I put in here. This one is already at partial fraction decomposition. You use this cloverleaf here to go up or down the menu, and we stop at partial fractions because that's what the program is asking you to do. When we press enter, it shows you that it went to partial fractions, and then you enter the formula here, the equation here, integral here, and you have to press alpha first, and then you put 8 times. You have to use the times to tell the calculator that you want to multiply, of course, and make sure you do that. Notice that this is HJ now, so I'm going to go back and press alpha again, and There's 8. And then times, and you keep going and you put the whole formula in here, just like including the parentheses in here with a divide sign, and then you can get on with the program. I do that for all my programs in physics are here too. You know, you have to put the what you're looking for, you have to put the terms of the equation in here to make it operate. But I've already programmed this into this integral into the calculator, so I can save time, and maybe and it won't mess up. So I'm going to go back and do it again here. See if I can't get back to the home screen. I'm going to clear the home. This is the most important thing. F1 and 8, you clear this screen here. When you press F1 and 8, you clear the screen. And here we have index 8. I'm going to go back to the menu, and I'm going to put the equation in here. Remember, you have to press alpha and then the numbers for the equation. So I show you what you've entered. Here's the exact numerator and denominator of this integral here. And I say it's okay. You can change it if you press scroll or press number 2. You can press the numbers in front too. But I want to say it's okay and move on. So then I factor the denominator, which is the important thing for partial fraction. If you can't factor the denominator, you can't do partial fraction decomposition. So you have to do integration by parts or some other system for integrating these integrals. Now I find automatically that programmed in here that when the degree, the numerator is greater than the degree of the denominator, then by 1 or more, then you have to use long division. So I'm going to show you how long division. Here's long division. This is the divisor, and here's the numerator here. And first, I'm going to show you how to do long division. First, you divide the numerator by the denominator here and come up with this 2x, which is the quotient number 1. You multiply that times the numerator here. You have to put it on the, here's the x cubed, so you have to put x squared in here, and then x, and then no x values, you know, when you're doing long division. But you write exactly what you see on here on your paper here. Turns out to be minus x squared plus 11x plus 0. Third, you multiply again the divisor into the numerator. Excuse me. And come up with minus 2. That's the second quotient. So here's the total quotients here on top of the sign, you know, 2x plus minus 2. Multiply that times the divisor, numerator, and we're finished when you can't multiply or divide this into anything any more of the factors in the front. So here's the answer: 2x minus 2 plus the remainder, which is 19 times x plus 2, and then over the denominator here. And we're going to set up the partial fractions now. Here's the left side of the equation. There's got an equal sign in the, here's the left side here, 19x plus 2, and divided by the factored denominator. So we multiply that times a factor. We're trying to get rid of this and make these all linear, not fractions. Here's the right side of the equation. A over 2x plus 1, and b over 2x plus, you know, the factored denominator, times the factored denominator. And then when we do the common denominator and the simplify, reduces it to 9x, this here, 9 times x plus 2 equals a, 2x plus 1 plus b. And we choose x to make a equals 0, which is minus 1/2. And we substitute that in. And we're trying to find what the value of b is. So we made a 0, which is out of the equation now, so b is equal to minus 15/2. We're going to substitute that into the long division answer. And we substitute for b in here, minus 15/2 for b. You don't have to understand what's happening here, even though it is understandable if you're really into math, but just put this stuff on your paper and write it down, and you're certainly going to get this problem right. And when you do the computations of it, a equals 19/2. You set that back into the original partial fractions, and we set up the integrals for that. Here's the first integral. This one's going to be u substitution, because when you take the derivative of u substitution, it comes out with 2 dx. And so then we can eliminate the dx and get it into du. Take the constant out of the integral. We always do that. Any constants come out. Set up our u equals 2x plus 1, du equals 2 dx, and then we isolate the dx here. We're trying to get rid of the dx on the original integral. And so here we have the setup here, and the answer is 9/4 times log of 2x plus 1 plus c. Second integral, minus 15/2 divided by this. We use u substitution again. Constant out of the integral. Set up the u's, and we substitute, doing an integrating, you know, when you have to move the u up into the top here with a minus exponent. We integrate, and here's the answer: 5/4 divided by 2x plus 1 plus c. And we have, remember the long division thing where we had the 2x plus 2 out in front. When we integrate that too, we come up with x squared minus 2x plus c. And so the whole problem answer is this: 9/4 log of 2x plus 1 plus 15/2 over 2x plus 1 plus x squared plus. Notice the nonsense of calculus. Incidentally, you know, Google keeps me from the front page, which I mentioned earlier, because an integral is the area under a smooth curve. You know, this graphable curve better be smooth. So you found now the area. This is the area. If you put a value for x in here, you're going to come up with a certain number, and that's the area of the graphable integral, and the original function. So notice how this cannot solve anything really useful. This is, and I've said that 30 years, I haven't found one useful thing that calculus has solved. Not one useful thing. You can make anything an integral, because you take just a number with respect to x, and you got number 2 with respect to x is 2x, so you've integrated that, you know. And it's all just a million problems like Sudoku or crossword puzzles to solve. And we just solved this puzzle here. Here's the puzzle. What's the decomposition of this? This was the puzzle. Doesn't solve anything, doesn't make any difference in life. It's not the Ohm's law in electronics, it's not Pythagorean theorem, it's nothing, you know. So anyways, but it sure makes you miserable during college. That's the reason I wanted to program this and get out of there. I couldn't stand it, and I couldn't stand what to study, you know. Like, for instance, studying this partial fraction. What are you going to study? You're going to study and become an expert like me in this stuff, where you just do it day after day after day. You have other things to study for in your calculus, in your college career. And, you know, you don't even know how to study or anything like that for the class, so it's really a waste of time. So we go back to new problems or the main menu, whatever, you know, so you've solved this problem. Make sure you write this down. Remember, college is scored on partial credit in the class curve all the time, so you don't have to get everything done. You just have to put down something intelligent in the test, and you get some points for it, you know. I got 26 in a physics test one time and got an A. So that's how they have to do it, because it's so difficult. All this stuff is so, you wouldn't believe programming this stuff, let alone doing partial fractions, you know. Think of the person who invented this, who came up with these systems, you know, years ago, way before probably Newton or anybody else, you know. Newton is the one who discovered calculus, him and Leibniz, in the 1600s. So anyways, good luck in your classes. Buy my programs and pass calculus or physics or whatever you want to pass, you know. You know, you load them into your TI-89 calculator, and you'll never get rid of the calculator. Get rid of your calculus book, but don't ever get rid of it. Once you load my program here, don't ever get rid of that, because you're going to have maybe children in the future that's going to need calculus. You're going to have partners, you know, in your life that may take advanced calculus, and all calculus is all the same. So what's in here will pass any test for calculus, you know, no matter how many years you forget about it. It's a language just like anything else, and you have to use it all the time to be good at it. But good luck in your classes, and you know, I'll help you all I can. You can call me up on the phone and I'll help you, or whatever, you know, with the programs, or you can give me your tests. I'll show you how to solve them with my programs. And these are all actually by tests. You'll never see this in a test. This problem here is way too complicated for that. When I have to do every one of these program on a piece of paper first and then program it, and of course this problem here is 4 pages of calculations that's in this just to do this stupid problem here. Good luck in your classes. Have a good one.